Hello, you're welcome to the channel. This is Inside the App. And if you're new here, we try to help you become a master in Web3 and blockchain development. So if you're excited about these topics, do well to like the video and subscribe to the channel. So kicking off today, we're going to continue with our series on Solidity for beginners. And today I have for you visibility specifiers. So visibility in Solidity is used to control who has access to functions and state variables in your smart contract. There are four different types of visibility in Solidity, and they include private, internal, external, and public. Today, I'm also going to be talking about function specifiers, which would include view and pure. So let's get started. So I'm going to define a state variable. I'm just going to name it age, and let's give it a value of 30. Now, by default, state variables have the visibility identifier of internal. So you can either expressly define internal or not have to define it, but Solidity would by default have this age variable that I've just defined of UINT 256 type as internal. So what does an internal visibility specifier mean? So when a state variable is defined as internal, or even a function, just as I'm going to define now, it means that it can only be accessed in the context of these smart contracts visibility specifiers that I've defined here. And it can also be accessed by inheriting smart contracts. That means smart contracts that inherit these visibility specifiers. And every other smart contract that inherits this contract will be able to access this age variable as well as this get age variable that I'm defining here, which should return age, which is of type UINT 256. I can also define a second variable and have it be private, and I can name it class. So let's just say class 1. So what's the difference between internal and private visibility specifiers? Private visibility specifiers can only be accessed within this visibility specifier smart contract that I've just defined. For instance, if I define a second smart contract, let's call it visibility2, I will be able to access the internal function in visibility specifiers, which is the first smart contract that I've defined. I'm just going to make an example. Oh, I forgot to inherit from the visibility specifiers contract. I also forgot the keywords. So this is view, and this is also view. I'm going to come back to view. And right here, you see that our smart contract compiles successfully. So what are we doing here? We created the first smart contract. We defined a state variable called age. And by default, this state variable is internal. And then we gave it a value of 30. Within this same smart contract, we defined a function called getAge, and we're returning the state variable age. But then we created a second smart contract called visibility2, which inherits from the initial smart contract we created. And as you can see, we are trying to access an internal variable in this smart contract, which is called age. And as you can see, we try to return age, which is the state variable defined in the initial smart contract we're inheriting from. And as you can see, the smart contract compiles successfully. So let's try this another way. Within the first smart contract, I'm going to define another function. I'm going to call it getClass. I'm also going to have this be an internal function. View keyword returns UINT. So I expect this to return the class. So as you can see, it compiles successfully because class is a private state variable and I'm trying to access it within the smart contract where it was defined. So let's try accessing it from an inheriting smart contract. So I'm going to say function get class 2, and let's see if we can access it. So as you can see, it errors. Unlike the first smart contract we created, where we return the age that was defined in the previous smart contract, which worked. Now we are trying to access class from the same smart contract where we accessed age from. And as you can see, it's throwing an error. Why is it throwing an error? Well, it's throwing an error because this function is a private function, which means that it can only be accessed within the context of this smart contract visibility specifiers. But what if we try to access this class from this internal function that was defined in get class in this function within the visibility specifier smart contract? Well, let's see how that goes. So I'm going to say return get class. And as you can see, the contract compiles. Why did it compile? Well, it compiled because, as you can see, the get class function in this visibility specifiers contract has the visibility specifier of internal rather than private. So what does it mean? It means that you can access internal functions within the primary smart contract as well as smart contracts that inherit from the primary smart contract. Hence, to summarize internal and private, internal functions can be accessed within the context of the smart contract where it was defined, as well as smart contracts that inherit the contract where it was defined. Whereas private variables can only be accessed within the smart contract where they are defined. So that's a major difference between private and internal visibility specifiers in a smart contract. So I'm going to go down to public functions. So for public functions, I'm going to define a function and say get age public. And then for the visibility specifier, I'm going to say public. View returns, you won't type. And then I'm going to return age because that's what this function is supposed to be doing. And then I'm going to define another function. I'm just going to make this an internal function. And I'm going to try to access the get age public function that we defined here. So as you can see, the contract successfully compiles. So for public functions, you'll be able to access them from outside the smart contract where you're defining it, as well as within the smart contract where you're defining it. Next, I'm going to go into the external functions so that I'll be able to show you the differences between an external function and a public function. So I'm going to define another function. Let's call this one get class external. So I'm going to make this an external function. I'm going to return class. As you can see, the function successfully compiles. How about we try it this way? So I try to return the external function that we defined here, which is get class external. And as you can see, the Solidity compiler complains. It doesn't compile. Why? So this doesn't compile because external functions aren't meant to be accessed within the smart contract where you are defining them. You can only access external functions from outside the smart contracts where you have defined them. Whereas for public functions, you can access them from outside and within the smart contract where you've defined them. So that's the major difference between an external and a public function in Solidity. So I'm also going to try to access these external and public functions from this visibility 2 smart contracts that is inheriting from the visibility specified contracts that we have defined. So I'm going to go ahead to create a function to do that. So I'm going to try to access this public function that we've created here. And let's see if the compiler will complain or not. So as you can see, the compiler does not complain. Why? Because getAgePublic, which is a public function, can be accessed from within the smart contract that defines it and outside the smart contract that defines it. So as you can see, over here, where we try to access this getAgePublic function, the compiler does not complain. And over here, which is a smart contract that is inheriting from the visibility specifier smart contract where we've defined this function, you can see it compiles as well. The compiler does not complain, which means that you can be able to access public functions from within and outside the smart contracts where they are defined. So let's try this same thing with the external function that we have defined. And for this, I'm going to define another contract. Visibility3. This time, I'm not going to inherit. I'm just going to directly import. And this time around, I am importing this contract. I'm just going to call it contr. And then I'm going to define a function. So I'm going to try to access this contract that we've defined here, which has the function of getClassExternal, which is what we're trying to define. And as you can see, the compiler does not complain. It compiles successfully. So what is happening here? Let me go back to the initial smart contract that we defined. Over here, as you can see, where we define the internal function getAge, and we know getAge has an internal identifier. So we were able to access age within the smart contract where it was defined. And we were also able to access the same age state variable from an inheriting smart contract. And next thing, we defined getClass, which is an internal function. We're also as well able to access the getClass function directly because it's internal from this smart contract that is inheriting it. And then for the public function, we declared a function, we gave it the public identifier, and it returns a uint type. We're also able to access this public function within the same contract that defined it by defining another function and accessing the public function that we have defined here, which means that public functions can be accessed from within and outside the smart contract. And then we went ahead to define an external function, but we were unable to access the external function from within the same smart contract that defined it. But then we inherited the visibility specifiers contract in the second contract that is importing it. And as you can see, we were able to access the public function getAgePublic. Because it's public, it means we can access it from within and outside a smart contract. Then for the external function that we were unable to access within the same smart contract that defined it, as you can see, the compiler did not throw any error when we tried to access it from outside the smart contract. Why? Because external functions can only be accessed from outside the smart contract and not within the smart contract importing it, and also not the smart contract that defined it. I hope this clears your doubts on external and public functions. What if I try to access these internal functions from this visibility3 contract that I've defined here? Let's see if it's going to work. So to access this, I'm going to first of all identify the pointer that I've created here. And as you can see, the internal function getClass is not available because it's only internal and available to the visibility specifiers contract itself or contracts that inherit the visibility specifiers contract. But as you can see, this visibility 3 contract does not inherit from the visibility specifiers contract, which is why we cannot access it directly. But even though I try to forcefully do it, the compiler is still going to throw an error, as you can see, because that was an internal function. And in this context, it looks as though we are trying to access it from an external smart contract, which is not visible to us. Hence why we're getting the error. But of course, the case would be different if we wanted to access the getAge public function that we created in the visibility specifiers smart contract. Let's see how that goes. So I'm going to comment this out since it doesn't compile and declare the next function. I'm going to try to access it from the pointer we've created. And as you can see, the compiler does not throw any error. Why? Because getAge public is a public function, which means we can always access it from outside and within the smart contract that defines it. I'm sure you must have seen a lot of view. I'm going to show you a little illustration about the view and pure keywords. So as you can see, for the view keywords, it's only used in read-only functions that do not update the state of the blockchain. And we tend to use view when the logic of the function that we are defining accesses a state variable or function within the smart contract where it is being used. So for instance, in this getAge function that we have used view, we're accessing the age state variable. In this getClass function that we have used view, we're accessing the class state variable. In this getAge public function that we have used view, we're accessing the age. And as you can see, in this getAge public function that we have used view, we're also accessing a function in the smart contract. How about the pure keyword? So I'm just going to go ahead and define another function. I'm going to name it pure func. I'm going to make it public. Let me just write view and see what the compiler has for us. Let's say I return a constant variable value. As you can see, it compiles, but it compiles with a warning. Why does it compile with a warning? It's telling us to use the pure keyword rather than the view keyword. So I'm going to change it to pure. And as you can see, the warning goes away. So why was it warning us? Well, as you can see in this function, we are not accessing any state variable or any function within this function logic. So a pure function is a function that does not update the state of the blockchain and as well does not depend on state variables or functions within the smart contracts where it is defined. So to summarize, private functions are functions that can only be accessed within the smart contract where they are defined. Public variables. For internal, state variables that do not have any identifier by default carry the internal specifiers. And also, internal variables are accessible within smart contracts where they are defined, as well as smart contracts that inherit the smart contract that defines them. For public functions, they can be accessed within the smart contract where they are defined and outside the smart contract where they are defined. For external functions, they can only be accessed from outside the smart contract where they are defined. For view specifiers, they can only be defined in functions that do not update the state of the blockchain, but depend on state variables or other functions defined within the smart contract. While for pure specifiers, they can only be used in read-only functions that do not depend on state variables or other functions within the smart contract. I hope I've been able to break down smart contract visibility specifiers in Solidity. If you have any question, please do well to ask in the comment section. If you enjoyed the video, please hit the like button, subscribe to the channel, do well to share. I'll see you some other time. Bye-bye.